right, so if you can turn to page 9 in your packet, we're going to talk about solving radical equations. Now, at the top of the page, there's some steps, and we're just going to follow right down the list in order to solve these. Okay, so step number 1 says to isolate the radical. So what that means is we want to get this radical right here all by itself. So we need to get rid of this 1. All right, so in order to do that, let's just subtract 1 from both sides of the equation. So that's going to leave us with x minus 1 equals radical x plus 5. Okay, so step number 1 is done. Now step number 2 says to square both sides of the equation, if it's a square root, which in this case it is. And the reason we do that is because in order to cancel off a square root, we just square it, right? A square and a square root cancel each other off. So we're going to square both sides of the equation. Now when you square the left-hand side of the equation, just because it's a binomial, make sure you put it in parentheses so the whole thing gets squared. Now, if you want to take x minus 1 and square it, keep in mind, you can't just take this exponent and distribute it into both terms within the parentheses, because this is a binomial. You have two terms separated by a subtraction sign. You can only distribute in the parentheses, an exponent in the parentheses like that, when you have one big monomial, right? If there's no addition or subtraction within there. But anyway, if something's squared, it just means there's two of them. So let's take the x minus 1 and write it out twice. And then, like we said, on the right-hand side of the equation, a square and a square root cancel each other off, leaving us with just what was underneath the radical, which is x plus 5. All right, so let's just solve from here. Let's double distribute. So x times x is x squared. X times negative 1 is negative 1x. I'm just going to write negative x. Negative 1 times x is another negative x. And negative 1 times negative 1 is positive 1. And then I'll bring down the x plus 5. And by the way, right now we are doing step 3, which is to solve. All right, so now since we have an equation with an x squared in it, we want to get everything to one side of the equation. So I'm going to subtract this x and subtract this 5. That way we get everything to the left-hand side of the equation. By the way, if you wanted to, you could have first combined these like terms, but I figured, that's just an extra step. Let's not even bother. We'll kind of do that all at once. All right, so on the right-hand side, everything cancels, leaving us with 0. And on the left-hand side, I'm going to bring my x squared down. And then we have a negative x, another negative x, and another negative x. So altogether, we have negative 3x. And then 1 minus 5 is negative 4. All right, so from here, let's just factor. Since we have a 1 in front of our x squared, we can just right away set up two sets of parentheses. And we can put an x in the first spot in each of those parentheses. And then we just want to come up with two numbers that add to negative 3 and multiply to negative 4. So negative 4 and positive 1. All right, so then we're going to just make a t-chart, and over here we're going to get x equals positive 4, and over here we're going to get x equals negative 1. Now step 4 says we have to check, and it says this is a must. Not all solutions will check. So this is actually a really important step, because a lot of times, you will have solutions, even if you solved everything correctly, just that don't check. All right, so check number, I'm going to number these. Check number 1. Let's first take the 4, and when we check, we always plug it back into the very original equation that we were given here. So what I'm going to do is I'm going to replace this x with a 4, as well as this x with a 4, and let's see if it checks out. All right, so that gives us 4 equals 1 plus radical 4 plus 5. All right, so let me bring down the 4 equals, and then 1 plus, well, 4 plus 5 is 9, and the square root of 9 is 3. And since 1 plus 3 is 4, we do get 4 equals 4, and this checks. So I'm going to go back and circle x equals 4. Okay, now let's check the negative 1. So this time I'm going to replace my x's in the original equation with negative 1s. All right. Now when I do that, I'm left with negative 1 equals 1 plus, well, negative 1 plus 5 is 4, and the square root of 4 is 2. Now when I add the 1 and the 2, on the right-hand side of the equation, that gives me 3. It does not give me negative 1. So this check doesn't work. So I'm going to go back to my x equals negative 1 and cross that off. And what we call that is an extraneous root. Okay, it's an extra root that just does not check in our equation. Okay, so that's an extraneous, that's an S at the end, extraneous root. All right, number 2, we're going to solve it the same exact way. So the first thing we want to do is we want to isolate the radical. So in order to do that, I'm going to have to get rid of the 2 on the same side of the equation as that radical. So when I do, I'm left with x minus 2 equals radical 9x minus 36. Okay, step number 2 is to square both sides of the equation. And the reason we do that again is because a square and a square root cancel each other out. All right, so anyway, on the left-hand side of the equation, since x minus 2 is being squared, it means we have 2 of them. And when you square a radical, they cancel each other out. So I'm left with 9x minus 36. All right, so this is really similar to what we did in number 1. So we're going to double distribute, giving us x squared minus 2x minus 2x plus 4. And again, if you want to combine your like terms on the left-hand side of the equation, you can. But I'm just going to do it as I bring the terms from the right-hand side over to the left. I figure I might as well just kind of combine them all in one step. So what I'm doing here is I'm getting my equation set equal to 0. Okay, so everything on the right here cancels, so there's my 0. And on the left, I'm going to have an x squared. And when I combine my negative 2x, and negative 9x, that's going to give me negative 13x. And then when I combine my positive 4 and my positive 36, that gives me positive 40. Okay, again, this is a pretty straightforward factoring question. Since we have a 1 as our leading coefficient, right, a 1x squared, that's when we're able to just jump right in and set up 2 sets of parentheses. I can put an x in the first spot in each of those parentheses. And 2 numbers that add to negative 13 and that multiply to positive 40 would be negative 8 and negative 5. So when we make our t-chart, we wind up with x equals 8 and x equals 5. Okay, and then let's do our mandatory step number 4. Let's do our check. Okay, let's see if we have any extraneous roots again. All right, so check number 1. I'm going to take the 8 and substitute it back into the original equation. So that'll give me 8 equals 2 plus the square root of 9 times 8 minus 36. Okay, so 8 equals 2 plus. Well, 9 times 8 is 72, and 72 minus 36 is 36. All right, so the square root of 36 is 6. And since 2 plus 6 is 8, this one checks. So I'm going to go over and circle x equals 8. Okay, check number 2. Now I'm going to take the 5 and substitute it back in wherever I see an x into the original equation. Okay, so I'm going to bring down my 5 and my equals 2 plus. All right, so under the radical, 9 times 5 is 45, and 45 minus 36 is 9. So we have the square root of 9, which is 3. And since 2 plus 3 is 5, this one checks as well. So this time we have 2 solutions. Okay, so now we're going to skip ahead to number 5. So you're going to have to turn to page 11 in your packet. And the reason I want to do this one with you is this one's a little different. What you'll notice is that we have, within this one equation, we have 2 separate radicals. So step 1 says to isolate the radical, well, since we have 2 of them, what we're going to do is we're going to isolate one of the radicals first. It does not matter which one you isolate first. I'm actually going to isolate the more complex one first because I think it's going to make my my job a little bit easier when it comes to solving. So the first thing I'm going to do is I'm going to subtract radical x from both sides. And by doing so, I've actually isolated the radical x plus 3. All right, on the right-hand side of the equation, I'm left with 3 minus radical x. Now, once you've isolated one of the radicals, you can do step number 2, which is to square both sides of the equation. Okay, so I'm going to square the left-hand side, and I'm going to square the right-hand side. Now when I square the left, we know that a square and a square root cancel each other off, so I'm left with x plus 3. Now when you square the right, I'm going to have to write that out twice, right? 3 minus rad x squared means I have 2 of them. And I'm going to double distribute. Now, in this step when I square both sides of the equation, I haven't eliminated the radicals altogether because I still have these, but we'll worry about that in a minute. So let me first bring down this x plus 3, and then when I double distribute, I'll have 9 minus 3 radical x minus another 3 rad x, and then negative radical x times negative radical x. Well, a negative times a negative is a positive, and rad x times rad x is just x. All right, so what we want to do, you know what I'm going to do first? Let me just combine my like terms here. All right, that way we can get all the radicals into one. So when I do, I'm left with 9 minus 6 radical x plus x. Okay, so now we're going back to step number 1 again, which is to isolate the radical. You want to get the radical all by itself on one side of the equation. So in order to do that, I'm going to have to get rid of this 9 as well as this x. Okay, so these are going to cancel. So I'm going to have a negative 6 radical x on the right, and on the left, and my x's cancel, and it just leaves me with negative 6. Now, from this step, it's up to you. If you want to completely isolate the radical, you can divide both sides right here by this negative 6, and you'll get the radical by itself. But if you decide to square both sides of the equation at this point, you can totally do that, even if there's a number being multiplied in front of your radical. So that's up to you. Let's see, I'm going to actually divide by negative 6. I'm just going to get rid of it. So if we divide both sides by negative 6, that leaves me with 1 equals radical x. Okay, and now we can, the radical is isolated, so now we could square both sides of the equation. And when we do, it leaves me with 1 equals x. So in this example, we only have one solution to check this time. All right, but even still, we have to check it, because if it works, then x equals 1 is our solution. And if it doesn't work, then we have no solution, and sometimes that happens. All right, so let's plug in the 1 back into the original equation wherever we see an x. So we'll have the square root of 1 plus the square root of 1 plus 3, and we want to know, does that equal 3? The square root of 1 is 1, and since 1 plus 3 is 4, the square root of 4 is 2. And in this case, it does check, because 1 plus 2 is 3. So in this case, we do have a solution, and it's x equals 1.